Hi, in this video, I'm going to discuss uh, the second eight of SLIMCC 8th paper given last year. Okay, let's go to the questions. Let me share the whiteboard. Okay, hope you can see my whiteboard. And we're going to start with number 9. What is the remainder when negative 10 is divided by 3? Now, to answer this, you should know the division algorithm. Which says that if you take an integer a and a positive integer b, right, then if you divide a by b, right, we get a quotient q, right, plus a remainder, right, and the division algorithm says that the remainder r is always non-negative and sorry, that should be r, and it is less than b, right? Again, once again, a is an integer, it could be negative also, but b is a positive integer, right? And when we divide a by b, we get a quotient q, right? And a remainder, and the remainder is non-negative and less than b. So b is called the divisor and a is a dividend, right? So if you apply that, so a is negative 10, right? And b is 3, and then we get a remainder which is non-negative, right? And furthermore, this algorithm says that this r and q are unique. The quotient and the remainder are unique, right? So how do you get negative 10 as a multiple of 3, right? And a non-negative remainder, right? So if you think a little bit here, you can see that when you multiply 3 by negative 4, you get negative 12. So let me rewrite that because it's not clear, right? So negative 4 times 3, which is negative 12, and then to get negative 10, we should add 2, right? So then 2 is the remainder when you divide negative 10 by 3 by the division algorithm, because this is negative 4 and 2 are unique, right? So therefore, the remainder when negative 10 is divided by 3 is 2, right? Okay, so that's the answer. Now, number 10, how many 3-digit numbers are there such that the hundredths digit is 4 more than the ones digit? Okay, so 3 boxes for the 3 places, 3 digits, right? And so hundredths digit is 4 more than the ones digit. So we can start with 4 in the hundredths place. 4, and then its digit is 0. So now it is 4 more than the hundredths digit. Digit is 4 more than the ones digit. So let's look at all the possibilities. So when the hundredths digit is 5, then its digit should be 1. When the hundredths digit is 6, then its digit should be 2. And when the hundredths digit is 7, the units digit should be 3. And the hundredth digit is 8, the units digit should be 4. And the hundredth digit is 9, the units digit should be 5. So we have 6 cases. So these are cases. Like in each case, the tens digit can be one of the digits, one of the 10 digits. So that means by the multiplication principle, for each case, we get 10 numbers. For each case, we get 10 numbers, right? So there are 6 cases. So that means we have 6 times 10, which is 60 numbers. So 60 is the answer, right? Right. Number 11. Sita shared a rectangular bar of chocolate with lines drawn parallel to the sides, forming small squares. And that's how chocolate bars are. With a sister by breaking off an entire of 8 small squares for her, right? So let's draw a figure. So drawing the figure is always helpful when you can, right? So one row, right, is for the sister, and it has 8 small squares, right? Then she broke an entire column of 7 small squares, right, for her brother. So here, the remaining bar, and then entire column of 7 small squares for her brother, right? How many small squares were there in the entire bar of chocolate? So, from the figure, we can see that it has to be, so this is one square, right? It is actually 8 times 8, 64 squares, right? So that's easy, right? Okay, so let's go to the next question. Sarat, Abdul, Meena, Kamala, and Susan have different numbers of marbles, totaling 195 marbles. What is the greatest number of marbles can the person with the least number of marbles have? So, now to make the one who has the least number, has the greatest, right? So we have to make the difference, right? Bare minimum between 5 people. What's the bare minimum? It is 1, because the numbers have to be different. So each one differs by 1, right? The number of marbles. So then the smallest one, let's say, have n number of marbles, right? Then the next one should have n plus 1. The next one should have n plus 2. And the next one should have n plus 3. And the next one should have n plus 4. And then the total is 195. Now, if we solve this, we can find n. So there are 5 n's, right? Plus 1 plus 2 plus 3 plus 4, which is 10, right? It's equal to 195. So, n is equal to 195 minus 10, which is 185, divided by 5, and that is 37. So n is 37. So that means the answer is 37, right? Okay. So let's go to the next question. Number 13. In the following diagram, the areas enclosed by 4 different shapes, square, circle, triangle, and rectangle, represent the multiples of 5, multiples of 9, multiples of 90, and multiples of 180, and the correct relationship between them. But we don't know which area represents which. So what is shape that encloses the area that represents the multiples of 90? Now, immediately you can see that, right? So 90 is a multiple of 9, right? So, so the area which represents 9 should include the area that represents the multiples of 90, right? And then 180, right, is a multiple of 90, right? So that means, right, we should have 3 areas. The bigger one encloses the multiples of 9, and then multiples of 90, and then multiples of 180, right? And you can see that, so that requirement is satisfied by circle, triangle, and rectangle. And the square must be the multiples of 5, right? Anyway, the question is, which shape that encloses, what is the shape that encloses the area that represents the multiple of 90? So it has to be the triangle, right? So the answer is triangle, right? Okay, right. Next question. How many 4-digit numbers consist of distinct even digits? Once again, I'm going to draw 4 boxes, which helps me to visualize the question and what to do, right? And then consists of distinct even digits. We know the distinct, yeah. So there are 5 even digits, 0, 2, 4, 6, 8. Now for the leftmost box, the thousands digit, it can't have 0. So there are 4 choices, right? And once you select one, right, to make the numbers distinct, right? So we need to take one less, but then 0 comes in. So that means for the next box is also we have 4 choices. And for the next one, 3, 2. So if you multiply all these choices, right, together, right, you get the number of 4-digit numbers. So that is actually 16 times 6, right, which is 60 plus 36, 96. So 96 is the answer, right? Okay. Now, this is by the multiplication principle, which you should actually know, right? If you do not know, you can Google it up, right? Right. Number 15. How many four letter sequences can be formed using A, B, C, D, E, or F if letters can be repeated and so there's a type, right? And E has to be selected, right? That's a typo. So there has many E, right? So there could be 1E, 2Es, 3Es, 4Es. So these are cases, right? So case 1, right? 4Es, right? Just one number, right? Case 2, 3Es, right? 3Es. Again, let's draw 4 boxes to visualize the 4-letter sequences, right? Now, this, okay, this very nicely, right? So 3Es, right? So one which is not E, that box can be selected in 4 ways. So 4, and that box can be filled in how many ways? So we cannot select E. So since there are how many letters? There are actually 6 letters, right? So we have so number of ways we can select the box which doesn't contain E and E, that is actually 4 ways. And then that box can be filled with 5 letters, one of 5 letters. So it is 4 times 5, right? Case 2, 2 E's. Now, in how many ways you can select 2 boxes for the E's, right? Now think about it. And you can see that, okay, let's do it quickly, right? I'm going to select an important color, red. So it could be this one and this. It could be, we'll later erase this, okay? This and this, and this and this, and then this and this, and this and this, and this and this. How many? 1, 2, 3, 4, 5, 6. There are 6 ways of selecting 2 boxes for the E's, right? So 6, okay, let's go back to our cool color, which is light blue, right? 6. And then the 2 boxes which do not contain an E can be filled in each one in 5 ways. So it is 6 times 5 times 5 by the multiplication principle, right? And then case 4, 1E. Now, this box can be selected in 4 ways, right? The box which contains E, other boxes in 5 times 5 times 5 ways And altogether, we get the total number of ways we can select 4-letter sequences, satisfy the given requirement. And what is that number? So 1 plus 20 plus, that is 30 times 550, plus 20 times 25, which is 500. And this is 176. So it is 671. 671 is the answer, right? Okay. I don't think we need to erase because we can read the problem, right? Okay. Number 16. Maria has 9 rupees 1 or rupees 5 coin. We don't know exactly how many in each she has. When her 9 coin values are written in each of 1 by 1 square of a 3 by 3 square, the sum of the numbers in the following shaded 2 by 2 squares are all equal to what is the minimum amount of money she has. Now, the shaded areas have 4 small squares. So if the sum is going to be 12, right? If all are actually 5s, it is 20, right? And here all are 1s, it is 4. And so 2 1s and 2, 1 5, 16. So you can see that there has to be 2 rupee 5 coins and 2 1 rupee coins to get 12, right? So 2 of the squares in the shaded area should be 5s, contain 5s, and the other 2 1s. That's how you get 12. There's no other way, right? Now, this should be true for all these 4 shaded areas. And then you have to think how it can be arranged, these 1s and 5s. So always think about, in like, a pattern. For example, I can say, straight away see that, right? I can see that if I put the 5 rupee coins like this, right? Then I do satisfy the given requirement, right? In each of the shaded regions, we have 2 5 rupee coins. Maybe I should write 5s, right? Not, the crosses, right? Because it complicates things, right? Let's write 5. So 5 here, 5 here, 5 here, 5 here, and other squares have 1s. Is it the only way? Well, if you think about it, right? You can have actually 4 corners, right? 5 is in 4 corners, and then 1 in the middle, right? So 1, 1, 1, 1, right? Right. Are there any other ways? How about this row, right? 5, 5. So let's check shaded areas. Yes, it is satisfied. Not 1, right? Not cross. It's 1. 1, 1, 1, 1, 1, 1. Now that is definitely lesser than these two, right? But is it the only way? Well, it looks like we can have 2 rows like this, right? We do not put anything in the middle, right? Let's see, 5, 5, 5. Yeah, that row satisfies. And you should check that there are no other ways, and the smallest would be this arrangement, and that has 3 5 rupees coins and 6 1 rupee coins, which totals to 21, and that is the lowest amount, the minimum amount, right? Okay, so we are done. We are done with the second 8 of SLIMCC 8 given last year. Okay, I'll see you again in another video in which I'll do the last 8 of SLIMCC 8 given last year. Okay, take care.